Let's define identity and inverse. Even if these are terms you haven't heard in a while, you've probably heard them before. An identity is a number that when I apply it to another number, it doesn't change the first number's value. So let's define that a little more clearly. A number that when applied to a number x, won't change the value of x. So for now, I know that's a little confusing. Let's think about addition. Think about a number that I can add to any other number and it won't change my value. So in other words, I want something where 3 plus this number still is 3. And I want something where negative 17 plus this number is still negative 17. At the same time, when I'm multiplying, I want something where, for multiplication, we're going to use a different number. So we're looking at an additive identity and a multiplicative identity. If you haven't already thought of the additive identity, it's 0, because anytime I add a number to 0, I get the number I started with. So try to find a number that does the same thing for multiplication. So in other words, 3 times this number is going to give us 3. And negative 17 times this number, oops, I told you, is negative 17. Our multiplicative identity is 1. Let's take a moment to define the word inverse. An inverse is a number that, when applied, brings us back to our identity. We've already talked about the additive inverse. Anytime we add a number's opposite, we end up with 0. So if I take 3 plus negative 3, I end up at 0. If I take negative 17 plus positive 17, I end up at 0. So the additive inverse is going to be the opposite. I just take the opposite sign of what I started with. The multiplicative inverse is also a word that you've seen before. All right. So think about it on your own. Take 1/4. I want to multiply it by some fraction and end up with 1, or 4/4. So pause the video right now, see if you can come up with what number it would be. In fact, it is the reciprocal. Because when I multiply 1/4 times 4/1, I end up with 1 times 4 is 4 over 4 times 1 is 4, which then simplifies to 1. This will work any time I multiply by the reciprocal.